5.4, the graph of a rational function. To graph a rational function, the first step is to factor the numerator and denominator of it, find the domain, write r in lowest terms, that's just saying simplify if you can. Find the intercepts of the graph, use multiplicity to determine the behavior of the graph of r at each intercept. Find the vertical asymptote or asymptotes, determine the behavior of the graph of r on each side of each vertical asymptote. Find the horizontal or oblique asymptote. Find points, if any, where the graph of r intersect the asymptote. Use the real zeros of the numerator and denominator of r to divide the x-axis into intervals. Determine whether the graph of r is above or below the x-axis by choosing a number in each interval and evaluating r. Then we're going to use all of those steps to actually graph our rational function. Let's graph our rational function. R of x equals x minus 1 over x squared minus 9. Please change that to x squared minus 9 on the denominator. Alrighty, our first step is to factor. So we can factor because our denominator is a perfect square, so we can factor the denominator. We can factor that into x plus 3, x minus 3. Now we can go ahead and find the domain. Because this is a fraction, the rule is bottom can't equal to 0. So you just set the bottom can't be equal to 0. So for our domain, our bottom is x plus 3, x minus 3. And the rule is the bottom can't be 0. So we're just going to set each factor can't equal 0. So we say x plus 3 cannot equal 0. X minus 3 cannot equal 0. So we say x cannot be negative 3 and x cannot be positive 3. Step 2 is to simplify if we can. We cannot simplify anything. We can't cancel out anything because there's no common factors. So we just keep moving on with our life. Step 3. Step 3 is to find our intercepts. So the most important one is the x-intercept. And then we also have the y-intercept, but we're going to do that after. So for fractions, this is a trick. So back in chapter 3, I gave you this hint and showed you why you're allowed to do this. When you're finding x-intercepts of a fraction and only fractions, you set the top equal to 0 and you solve it. That is a nice little trick, and the reason why comes from chapter 3.2. So let's set the top equal to 0. So our top is x minus 1 equals 0, and we get x equals 1. That means our x-intercept is 1, 0. Now we have to find our y-intercept. There's no trick for the y-intercept, you just find it. So we just find it by making x equals 0. So we have y equals 0 minus 1 over 0 squared minus 9. We just plug in 0 for x, and when we simplify, we get negative 1 over negative 9, which is positive 1/9. So our y-intercept is 0, 1/9, but since we're graphing, it's easier to graph decimals, and 1/9 is about 0.1. I just plugged it into my calculator, and it's about 0.1. Alrighty, our fourth step is to find our vertical asymptote. What's great is if you found the domain, which you should have, that is your vertical asymptote. Your vertical asymptote is always your domain. So our domain was x cannot be 3 and negative 3. That means our vertical asymptote is negative 3 and positive 3. Alright, step 5 is to find our horizontal or oblique asymptote. Remember, it's one or the other or none. You can never share horizontal and oblique. It's always horizontal or oblique. So what we do is we look at our numerator and our denominator. So if we look at the degree of the top, it's 1, because it's x, so it's just to the power of 1. If we look at the degree of the bottom, it's 2, because it's x squared. So the degree of our numerator is 1, the degree of our denominator is 2. So that means the top is less than the bottom. If the top is less than the bottom, always, it's rule number 1. Going back to 5.3, that's rule number 1. And rule number 1 states you have a horizontal asymptote at y equals 0. You don't need to tell me the rule number, you just got to give me the asymptote. Alrighty, step 6, that's what this chart is for. This is called a fancy t-chart. It's actually called an interval chart, but I like to call it a fancy t-chart because at the end of the day, that's all it is. It's just a t-chart that you pushed over. We're going to pick an x, we get a y, we're going to figure out the location. So what we put on our interval chart are all the x values we have, those intervals. So that's why we have our number line. A number line represents all of our x values. So what we're going to do with our number line is we're going to list all of our x's. So all the x's we found, I'm talking everything with an x. So our domain, that has an x, aka our vertical asymptote, and our x-intercept. So our domain and our vertical asymptote, they're the same thing. So we have an x at -3 and +3. That comes from the domain. Then we have an intercept, an x-intercept at 1. So everything with an x value goes on this number line. We found everything with an x. It was the domain slash vertical asymptote and our x-intercept. And we just list them. Now we find our intervals. So this comes from -infinity and it stops at -3. So that's -infinity to -3. Then we pick up again from -3 to 1. Then we pick up again from 1 to 3. And then we have 3 to infinity. This comes from chapter 1.5 and 1.6, our intervals and number line. So what we do with each interval is pick a number between that interval. So if we have -infinity to -3, that means we want to pick a number smaller than -3. You always want to pick the next number. So the smallest number next to -3 is -4. Alright, now we want to pick a number between -3 and 1. You can pick -2, you can pick 0. The reason why we don't pick x equals 0, because we already have that. Y-intercept is when x equals 0. So for your interval chart, don't mess with 0, because you're already using it. So a number between -3 and 1, let's say -2. A number between 1 and 3, let's say 2. If you can, pick the opposites of numbers, -2 and +2. And then a number between 3 and infinity, so the next number would be 4. So what we're going to do is plug each of these in. Now, there's two ways you can do it. You can plug -4 in for x and solve for y. You can plug in -2 for x and solve for y. You can plug each of these numbers in to x separately and get y. However, if you have a TI-84 or a graphing calculator, you don't need to plug these in individually. I'm going to show you how we can actually find our values using our graphing calculator. Right now, I'm just going to write the values down, and then I'll show you how we actually get them. Alright, now that we have our numbers listed, let's show you how we get them. Alright, with our calculator, it doesn't matter where you're at, just hit y equals. go down, scroll down, make sure there's nothing here. Make sure you scroll all the way down in your Y's and clear it all out, because if you don't clear it all out, it's going to mess everything up. So let's type in our fraction. Now, we actually want decimals because it's easier to graph decimals. So how we graph our decimals, we have a top and a bottom. So we have to wrap the top and the bottom. So our top, we have x minus 1, so parentheses, x minus 1. And then fractions are just division. So we divide by x squared minus 9. So because it's a fraction, we're going to wrap the bottom. We have x squared minus 9. So we have our function. Now we need to get our table, because that's all an x and y chart is, an interval chart. It's just a table. So to get our table, we hit blue button graph, second graph, and use your up and down arrows. So when we go to -4, it's -0.7. I have decimals here, that's okay. I have -3.5, -2.5, that's just how I set up. If we go to -2, it's 0.6. If we go to +2, it's -0.2. And if we go to 4, it's 0.4. So that's actually how we get our values. Now we need to determine the location above the, or if it's above or below. So it all has to do with your y values. If your y is positive, it's above. If your y is negative, it's below. So because we have -0.7, that's below. 0.6, that's positive, that's above. -0.2, that's negative, so that's below. And 0.4, since that's positive, that's above. So the intervals that it's above the x-axis is -3 to 1 and 3 to infinity. The intervals that it's below the x-axis are -infinity to -3 and 1 to 3. We have everything we need to graph now. So the first thing we're going to do is actually graph and plot our asymptotes. Asymptotes are plotted using dashed lines. So our vertical asymptote is -3 to 3, our horizontal asymptote is 0, and we have points 1, 0, 0.1, and then decimals. We have a bunch of decimals here. So how we want to arrange our x's and our y's on our chart is going to be, kind of particular. So for our x's, all of our x's exist between -4 and 4. Every x we have exists between -4 and 4. So that's what I'm going to do for my x's. I'm just going to go to 4. So my y values, though, the y values range from -0.7 all the way. We have 0.1, 0.6, 0.2, 0.4. So it goes from -0.7 to 0.6. So if we round that to the next whole number, that's 1. It's closest to 1. So what we're going to do is we're going to go by 0.2 until we get to 1. So here we have 0.2, 0.4, 0.6, 0.8, and then 1. Same thing on the bottom. So -0.2, -0.4, -0.6, -0.8, -1. Alright, our vertical asymptotes are at -3 and 3, so little dotted line. We have a vertical asymptote at -3, and then we have another vertical asymptote at +3. And we do label them. We have to label them to let the reader know what we're talking about. We have a horizontal asymptote at y = 0. Y = 0 is on x-axis. Alright, those are all of our asymptotes. Now let's start plotting points. I'm going to start from our intercepts. So we have an x-intercept at 1, 0. That's right here. We have a y-intercept at 0.1. So 0.1 is about right here. Alright, and then we have additional points. We have a point at -4, -0.7. So -4, -0.7 is right here, about. We have a point at 0.2, Now, sorry, negative 2.6. So negative 2.6, that's right here. We have a point at 2, negative 0.2, so 2, negative 0.2 is right there. And then our last point is at 4.4, so 4.4 is right there. We have all of our points plotted. Now I'm going to start in the middle and connect our dots. So in the middle, I'm going to use blue. We just connect our dots and approach the asymptote. So this, I mean, if you see the orientation, if we start to connect our dots, you see how it's naturally going down? So we're just going to keep going down until the asymptote. And here, we're just going to go up until the asymptote. Our opposite points, there's only one point in that little grid area. So you come from the asymptote, you hit the point, you go towards the asymptote. Same thing on our left side. You're coming from the asymptote, you go to the point, you go to the asymptote. And there is our graph. What's great about having a graphing calculator, even though you have to graph this by hand, we can just check ourselves. Make sure we graphed it right. We did. It looks about the same. Remember, everything you do by hand is a sketch, so it might be a little rough looking, but that's okay. I'm looking for your chart and your points. Alright, you graphed your first rational function. Alright, let's move to example 2. We have r of x equals x squared minus 1 over x. So our first step is to factor. So let's factor, and we can because the top is a perfect square. So we have x squared minus 1, that means that's x plus 1, x minus 1. And on the bottom, that's just x, so we can't do anything. Let's find our domain. Remember, the rule is bottom can't equal 0. So for our domain, we just set the bottom can't be 0, so the bottom is x, and it can't be 0. That's it, that's our domain. And we cannot simplify, because we can't cancel anything out, so we just move on to step 3. Step 3, we're talking about intercepts. So we have our x-intercept and our y-intercept. So for the x-intercept, remember, there's a trick. Set the top equal to 0. So our top, we have x plus 1, x minus 1 equals 0. So we have x plus 1 equals 0, x minus 1 equals 0. We have x equals negative 1, x equals positive 1. That means we have two x-intercepts, negative 1, 0, and 1, 0. Alright, we have a y-intercept now. So the y-intercept, to do that, we make x equals 0. However, the domain, you're not allowed. Since you're not allowed to have x equals 0, you don't have a y-intercept. So you don't have a y-intercept because the domain doesn't support x equals 0. If that doesn't support x equals 0, you're not allowed to have a y-intercept. It just doesn't exist. Alrighty, our fourth step is to find our vertical and our vertical asymptotes. So remember, your vertical asymptote, that's just your domain. So our domain is x equals 0. That means our vertical asymptote is x equals 0. Our fifth step, now we're talking about horizontal or oblique. Let's just see what we have. So we're going to look at our numerator and our denominator and the degree of that. So the degree of our the degree of the numerator is 2 and the degree of the denominator is 1. So the degree of the top is 2, the degree of the bottom is 1. The top is exactly 1 more than the bottom. Exactly 1 more. Remember, when it's exactly 1 more, we know that we have an oblique asymptote. So to find our oblique asymptote, we have to long divide. Whatever's on top goes inside the house, whatever's on bottom goes outside. So on top we have x squared minus 1, and on the bottom we have x. Remember, our goal is to make them the same by multiplying. So we need to multiply something to x to make it x squared. And what we can do is multiply by x, because x times x is x squared. So we multiply it back out. X times x is x squared. We change our sign, and we get 0. We bring down the negative 1. So all we're left with, 0 minus 1, is just minus 1. X, you can never multiply to x to be negative 1, because there's an x there. It can never be negative 1. So that means our oblique asymptote is y equals x. Alrighty, our sixth step is this number line and our chart. So on our number line, we put all of our x values. All of our x values right now is just the domain and x-intercept. So our domain, we say x couldn't be 0, so we have a 0. And then our x-intercepts, we had one at -1 and +1. So our first interval is -infinity to -1. Our next interval is -1 to 0. Our next interval is 0 to 1. And then our last interval is 1 to infinity. So what we're going to do is pick numbers in between those intervals. So a number between -1 and -infinity, -2. A number between -1 and 0, well, the only number there is 0.5. That's the easiest one, -0.5. A number between 0 and 1, well, 0.5 again. And a number between 1 and infinity, let's go ahead and pick 2. As always, I'm just going to write our values, and then I'll show you how we find them. Alright, before we show how to find them, let's determine if they're below or above the x or the x-axis. So if we look at -1.5, that's negative, so that's below. 1.5, that's above because it's positive. -1.5, since that's negative, that's below. And 1.5, since that's positive, that's above. Alright, doesn't matter where you're at, just hit y equals, make sure there's nothing there. So we want decimals because they're easier to graph. So because we have a fraction, we're going to wrap the top. We have x squared minus 1. And since we have a denominator, we are going to divide. Let's wrap it. You don't technically have to for x, but we're going to do it just to stay consistent. And you might not have, if you hit second graph, you might not have 0.5s. It might just be whole numbers. So how do we get to 0.5? How do we get to -0.5 and +0.5? What we're going to do is hit our window. What you want to make sure is that our table is going to be set to 0.5. So we hit second window. And your start, it doesn't matter. That can be any number you want it to be. Make sure independent or dependent are auto. What we do is delta TBL. That's the change of the table. So we want the table to change by 0.5 for every number. So make sure that's 0.5. Then you can hit second graph and get your 0.5s. So at -2, we got -1.5. At 0.5, or -0.5, we have 1.5. At +0.5, we have -1.5, and at +2, we have +1.5. Alright, let's graph our asymptotes. So all of our x's range between -2 and 2. All of our y values range from -1.5 to 1.5, so we really don't have to make a huge graph. Let's just make everything go by 2. Alright, our first asymptote is x equals 0. That's on the x-axis. Or the y-axis, sorry. That's on the y-axis. So we say x equals 0. Then y equals x, it actually just splits down the origin. Alrighty, so let's plot our points. We have -1 and +1 for our x-intercepts. We have -2, -1.5. We have 0.5, +1.5. We have 0.5, -1.5. And we have 2, 1.5. So you can kind of see the shape already. You can see how it's forming a shape using our asymptotes. Remember, we never, ever, ever cross a vertical asymptote. So we're coming from our asymptote, we connect the dots, go back to the asymptote. Same thing here, we're coming from our asymptote, connect those dots, and go towards back that asymptote. Ah yeah, it looks like it. Sweet. Alright, example 3. We have r of x equals x to the fourth plus 1 over x squared. So today you're really going to see an example of everything I can throw at you with every type of asymptote. Okay, our first step is to factor if we can. I can't factor anything. X to the fourth plus 1, that's a plus. It needs to be a minus to be factorable. X squared is just x squared, so I can't factor anything. Alright, I can't factor, so if I can't factor, I can't simplify. So that just leads us to finding the domain. So our domain is bottom can't be 0. That's the rule. So we're just going to set the bottom can't be 0. So x squared cannot be 0. That means x can't be 0. Alrighty, step 3. Let's find our x and y intercept. So our x-intercept, we just set the top equal to 0. So top equal to 0, we have x to the fourth plus 1 equal to 0. We have x to the fourth equals -1. I just subtracted 1. We square root, and then we get x to, well, we fourth root it because it's to the fourth, and we get a negative. You can't take an even root of a negative. It's not real. If it's to the second, to the fourth, to the eighth, if it's an even, you can't take a negative. So since we can't take a negative, it's not a real answer. There's no x-intercept. And guess what? There's no y-intercept. The reason why there's no y-intercept because x can't be 0. If x can't be 0, you have no y-intercept. We have no intercepts here. This graph does not cross the axis at all. How are we going to graph this? Just keep going. Just trust me on this. Just keep going. So our vertical asymptote is the domain, so we just have our vertical asymptote of x can't be 0. Or x is 0. Alright, our fifth step, we're talking about horizontal or oblique. Alright, so let's look at our numerator and denominator. If we look at our numerator, the degree is 4. If we look at the denominator, the degree is 2. So the top is 2 more than the bottom. That's rule number 4. Rule number 4 states that if the top is 2 or more than the bottom, you have no oblique or horizontal asymptote. However, it tells you end behavior. So it tells us something about end behavior. Let's find our end behavior. So our end behavior is leading term over leading term. So basically, where did the 4 and the 2 come from? So the 4 came from x to the fourth. The 2 came from x squared. We can simplify that down to x squared. So x squared, if we just did a little sketch of that, that's what x squared looks like. You're like, why are we talking about this? Don't you worry. That's how we're going to graph this thing. Just give us a second. All right, let's use our little fancy t-chart and our number line. That's step 6. So anything with an x goes on this number line. Guess what? You only have one thing with an x, and that's the domain and the vertical asymptote. So 0. So that means our first interval is -infinity to 0. Our next interval is 0 to infinity. So let's pick numbers. A number between negative infinity and 0, -1. A number between 0 and infinity, +1. As always, I'm just going to write down the answer, and then I'll show you how we get it. We get 2 for both. And since those are both positive, they're above. Alright, we have everything we need to graph. You're like, whoa, we don't have much. I mean, this is slim pickings to graph. Guess what? That is all we need. Going through the steps is always going to get you what you need to graph this. So as always, let's graph our asymptotes. We have a vertical asymptote at x equals 0. We have numbers between -1 and 1, and our y's are 2 and 2. So we really don't need much of a big graph. For my x's, we can just say, let's go to 2. And same thing for the y's. The highest y we have is 2. Alright, we have x equals 0. So x equals 0 is always on the y-axis. And then we do have other asymptotes. We have end behavior. So what we're going to do is actually copy the graph of x squared, but using dotted lines. Alright, let's plot our points. We don't have much. We only have 2 points. -1, 2, and 1, 2. That is it. However, you see how we have guidelines? So we always come from the asymptote and then go to the asymptote. So if we're coming from the asymptote, we hit the dot, we go back to the asymptote. We're coming from the asymptote, we hit the dot, go back to the asymptote. End behavior tells us that at the ends, we're going to have up, up. And guess what? We do. At the ends, we go up and up. We can plug it in. So first we got to plug it in to figure out how we get our answers. So wherever you are, hit y equals, clear that out. We have a numerator, so parentheses, x to the 4th plus 1. Close out the top, divided by the bottom, which is x squared. We hit second graph, and at -1 you get 2, and at +1 you get 2. If you want to check your graph, hit graph. Oh, look at that. Looks just like it. Example 4. Let's go ahead and graph r of x equals 3x squared minus 3x over x squared plus x minus 12. Alright, first things first, let's factor, domain, simplify. So our first step, we can totally factor. We can factor 3x squared minus 3x because they share a 3x. So if we take it out, we're left with x minus 1. The bottom we can factor because that's a trinomial and it's factorable. We can actually factor that into plus 4 and x minus 3. We can't cancel anything out. Nothing can be simplified, so we just go ahead and move on to finding our domain. So our domain is bottom, can't be 0. So we're just going to set the bottom to can't be 0. So we have x plus 4, x minus 3 can't be 0. So we have x plus 4 cannot be 0, x minus 3 cannot be 0. So we say x cannot be -4, and x cannot be 3. You don't have to show that work. I'm very aware some of you just know it's -4 and 3 because you don't need to set it equal to 0. It's just whatever opposite the term is. Alrighty, step 3. Let's go ahead and find our x and y intercept. Remember, the trick is for our x-intercept, top equals 0. So 3x, x minus 1 equals 0. That means we have 3x equals 0, x minus 1 equals 0. So x equals 0, x equals 1. If we have 0, 0, that means our y-intercept is 0, 0. That's the rule. If your x is 0, 0, always y is 0, 0. All right, step 4 is to find our vertical asymptote. Remember, your vertical asymptote is already found. It's just your domain. So our domain was x cannot be -4 or 3. So that means our vertical asymptote is x equals -4, x equals 3. All right, oblique and or not and or, just or. Oblique or horizontal. Remember, it's never, ever, ever, ever both. It's only one of them. So let's look at the numerator and the denominator. So if we look at the degree of the numerator is 2. The degree of the denominator is 2. They're the same. If they're the same, that's rule number 2. Rule number 2 states you have a horizontal asymptote of leading term over leading term. So our first leading term, that was 3x squared. Our second leading term was x squared. We can cancel those out, and we're just left with 3. So our horizontal asymptote is y equals 3. Our sixth step is to do our interval chart, meaning we have to do a number line and then our chart. So every x goes on this number line. We actually found quite a few x's here. We have our domain, our x-intercepts. So our domain was -4 and 3. That's also our vertical asymptotes. So we have -4 and 3. We have x-intercepts at 0 and 1. So 0 and 1. Now let's find our intervals. So we have an interval from -infinity to -4. We have an interval from -4 to 0. We have another interval from 0 to 1. We have an interval from 1 to 3. And then our last interval is 3 to infinity. Do you notice that you always have one more interval than your x's? We have 4 x's, we have 5 intervals. All right, let's find a number between each interval. So -infinity, -4, -5. -4 to 0, you can pick -1, you can pick -2, you can pick -3. I actually picked -2. Don't know why, I just picked that number. An interval between 0 and 1, 0.5. Always pick 0.5. If it's 0 to 1 or 1 to 2, if it's like really strict and you can't find another number, always pick the half. A number between 1 and 3, I picked 2. 3 to infinity, we pick 4. As always, I'm going to write our numbers and I'll show you how we get them. All right, so 11.25, that's positive. That means it's above. -1.8, since that's negative, that's below. 0.07, that's positive, so it's above. -1, that's negative, so that's below. 4.5, that's positive, so that's above. Let me show you how we get these values with our calculator. Doesn't matter where you're at, hit y equals, clear it all out. So we have our top, wrap it in that parenthesis. So we have 3x squared minus 3x divided by our bottom, which is x squared, plus x minus 12. And then let's go ahead and hit second graph. So at -5, we get 11.25. At -2, we get -1.8. At 0.5, we get -0.06. I just rounded that to 0.07. At 2, we get -1. And at 4, we get 4.5. Do you notice that it says error at the domain and the vertical asymptote? So that's another way you can find your vertical asymptote and domain. Just plug it into your calculator. We now have everything we need to graph. I know this is a lot. It's a lot of steps, but the more you practice, it just really flows nice and neatly. Okay, our y's range from negative 1.8 all the way to 11.25. Our x's range between negative 5 and 4. So for my x's, let's do negative 5. Alright, so for my y's, it's a little weird because we have 11.25, negative 1.8, 0.07, negative 1, positive 4.5. So it's a little odd on how we're going to put all of our values on this table, but we're still going to be able to do it, don't you worry. So for my x's, or sorry, for my y's, I'm just going to list what I need. So for my positive y's, I have 11.25, 0.7, and 4.5. So 0.07, let's just say it's right there. And then our next y value, the next y value we have is 4.5. We also have a y value at 3 because that's our horizontal asymptote. So here's going to be 3. And then we have another y value at 11.25. So 11.25, that's much bigger. So 11.25. My negative y's, we have negative 1 and negative 1.8. So we really don't have to do much for that. So let's say negative 1, negative 1.8. Alright, our vertical asymptote is at 3. So x equals 3. So x equals 3 is right here. And then we have another one at negative 4, which is right here. Alright, we have a vertical or horizontal asymptote at y equals 3. And let's plot all of our points. So we have x-intercept and y-intercept at 0, 0. We have a x-intercept at 1, 0. And then we have points. We have negative 5, 11.25. It's all the way up here. We have negative 2, negative 1.8. That's right here. We have 0.5, 0.07. So right there. And then we have negative 1, or sorry, 2, negative 1. So 2, negative 1. And then last but not least, we have 4, 4.5. All right, I'm always going to start in the middle because it is easier to start in the middle because you have multiple guidelines. All right, so if we connect the dots, you see how we have a natural curve? It's going back down, so we go back down to the asymptote, and there's no other dot to go here, so we just go back down to the asymptote. Our single ones, we go from the asymptote, hit the dot, go back to the asymptote. Same thing here. From the asymptote, hit the dot, go back to the asymptote. It's okay if it looks a little funky. My graphs don't look good by hand because they're all sketches. Now let's just double check. Got that. Yep, totally sweet. Looks like it. We're good. Do you notice up until this point, we have not simplified? Nothing's been able to be canceled out. We haven't been able to cancel out when we did steps 1 and 2. Everything's just been nice and neat, can't factor, or can't simplify anything. So what happens if we can cancel something out? What's going to happen to the graph? How do we have to be careful? That's example 5. So, if we have to cancel something out, we have to be careful that we have holes and crossing and stuff like that. We'll go through it as we go through it, and I'll show you when to be careful. So, step 1, let's factor and simplify. So we can factor the top. You can factor the top into 2x minus 1 and x minus 2. On the bottom, we can factor that into x minus 2, x plus 2. And we can cancel. Before we cancel, let's find our domain though. So our domain is x cannot be -2 or +2. You just set the bottom can't be equal to 0. Alright, now let's write it in lowest terms. The reason how I know we can write this in lowest terms because we can cancel two terms out. We can cancel out x minus 2, x minus 2. So in lowest terms, we have 2x minus 1 over x minus 2. So we factored, we simplified. If you can simplify, when we get to certain steps, we have to do some extra stuff. We can keep going though to find our intercepts. So we have x-intercept and our y-intercept. Remember, x-intercept is just top equals 0. And remember, we write it in lowest terms. So in lowest terms, that's how we're going to find our x and y-intercept and stuff like that. So in lowest terms, we had 2x minus 1 over x plus 2. So that means the top, we have 2x minus 1 and equals 0. So we add 1, divide by 2, and we get x equals 1/2. That means that point is 0.50. Our y-intercept, there's no trick. You just set x equals 0. And x is allowed to be 0, so we have to find it. So in lowest terms, we have y equals 2 times 0 minus 1 over 0 minus 2. So we have y equals -1 over -2. That's +1 over +2 now. So we know our y-intercept is 0, +0.5. I canceled out the wrong one. That's supposed to be plus. I'm sorry, y'all. That's supposed to be plus. That's supposed to be plus. That's supposed to be negative. -0.5. Alright, step 4 is our vertical asymptote, and remember, we're finding our vertical asymptote in lowest terms. So in lowest terms, we find our vertical asymptote. So our vertical asymptote, we only have one denominator, so we say x equals -2. Remember, we just set it equal to 0, subtract 2 over. So our vertical asymptote is x equals 2. We had to simplify here. Remember that. Since we had to simplify and write in lowest terms, that excludes a value from the domain. X cannot equal 2. That's not a vertical asymptote. Our only vertical asymptote is x can't be -2. So that means there's a hole. X equals 2 is a hole in the graph because we cannot have x equals 2. That's the domain. So we're going to plug x equals 2 to find the hole. Remember the hole, that means open circle. So let's plug it in. We'll have y equals 2 times blank minus 1 over blank plus 2. And in that blank, we're plugging in 2. So when we simplify this, we'll get 4 minus 1 over 4. So that's 3 over 4. So that's 0.75. That means we have a hole at 2, 0.75. So whenever you have to simplify and cancel something out, you then have to go back and figure out where that hole is going to be. All right, our fifth step is horizontal or oblique. So let's look at the top. So in lowest terms, our numerator is 1, our denominator is 1. Since they're the same, that's rule number 2. Rule number 2 states we have a horizontal asymptote at leading term over leading term. So our leading term for the top is 2x. The leading term for the bottom is x. We cancel out our x's and we get 2. That means our horizontal asymptote is at y equals 2. However, we have a hole. We have a hole. Don't forget we have a hole. Since we have a hole, we need to check to see if r, which is the graph, intersects the horizontal asymptote at y equals 2. You have to do this every time you have a hole. So if you cancel anything out, you have to see, is there crossing, are there holes, stuff like that. So what we do is we set the equation equal to 2. Why? Because that's what y equals. So we have 2 equals 2x minus 1 over x plus 2. We set it equal to 2, the lowest terms, and let's go ahead and simplify. So to simplify, I'm going to multiply by the denominator. And we have 2 times x minus 2 equals 2x minus 1. Let's go ahead and distribute. So 2x minus 4 equals 2x minus 1. Let's subtract 2x over. Those cancel, so we're left with negative 4 equals negative 1. Sorry, that's supposed to be plus. I don't know why my brain's doing that. My brain keeps wanting to put minus. Sorry. So we have 2 times x plus 2. That means we have 2x plus 4 equals 2x minus 1. We subtract 2x over, and we're left with 4 equals negative 1. That's not true. Since that's not true, we do not cross. If it was true, you would cross. So it's just showing, it's telling you how the graph is going to behave. So if it was like 4 equals 4 or negative 1 equals negative 1, if it were true, you were to cross and then you would know how to graph your graph. However, we're not crossing here because it's not equal. So we just keep moving on with our life. Step 6. That's our handy dandy chart and our number line. So on that number line, we're going to put every x value we found. We found 0.5, we found negative 2, and we found positive 2. Remember, you go from the domain and your x-intercept. So our domain was negative 2 and positive 2. Our x-intercept was 0.5. So our first interval is from negative infinity to negative 2. Our next interval is negative 2 to positive 0.5. Our next interval is 0.5 to 2. And our last interval is 2 to infinity. So a number between negative infinity and negative 2, negative 3. When you plug that in, you get 7. Since that's positive, it's above. A number between negative 2 and negative 5, I keep saying negative 5. Negative 2 and 0.5, let's say negative 1. A number between negative 2 and 0.5, negative 1. And when you plug that in, we get negative 3. Since that's negative, that's below. I will show you how we use our calculator to get these values. A number between 0.5 and 2, we chose 1. And you get 0.3. Since that's positive, it's above. A number between 2 and infinity is 3. When you plug that in, you get 1. Since 1 is positive, that's above. Let's go ahead and actually show you how we get these values with our calculator. Alright, again, it doesn't matter where you're at, just hit y equals. We're going to write it in lowest terms. So in lowest terms, we have parentheses 2x minus 1 divided by parentheses x plus 2. And then we hit second graph. So when it's negative 3, we get 7. When it's negative 1, you get negative 3. When it's positive 1, you get 0.3. And when it's 3, you get 1. We have everything we need to graph. So our x's range from negative 3 and 3, and our y's range from negative 3 to 7. And then we have a point. So we have points there. We have decimals there. That's okay, though. So for my x's, let's just go to 3, because that's all we need. For the y's, though, it's a little weird. We have 7 as the max, so let's just throw that as the max. And then we have negative 3.3, 1, and negative 0.5. So let's just list our values. Here, let's say is -3. Let's say this is 0.3. Let's say this is 1. And then we also have a 0.5, a -0.5. So let's say this is -0.5. And we also have a hole at 2.75. So 0.75, that's almost 1. So let's say 0.75 right here. And then we have our our horizontal asymptote at 2. So let's say 2 is right here. I just list all the values in order. All right, our vertical asymptote is x equals -2. So x equals -2 is right here. We have a horizontal asymptote at y equals 2. So y equals 2 we said was right here. All right, let's plot our points. We have an x-intercept at 0.50. We have a y-intercept at 0, -0.5. All right, we have a hole at 2.75. So 2.75, let's just create an open circle. And then we have more points. We have a point at -3, 7. That's up here. We have a point at -1, -3. That's right here. And then we have a point at 1.3. That's there. We have a point at -1, -3. I already did that color. And then we have our last point at 3, 1. See the shape of that graph? You can really see the shape now. So let's connect our points. What's great is you can really see that shape. Don't go through it. Remember, it's a hole. And then whenever you have one point, just use your asymptotes to guide you. So you kind of just, boop. Close enough. It works. Let's check our graph. Yep, that looks like it.